Hello, everybody. Welcome back to our Spotlight presentation session. I hope you all had time to go to the bathroom and have a coffee. Mine is still here. I just had to make it, but didn't yet have time to drink it, but I'm going to do it during the next minutes, and I hope you can do the same. So in this next block of the conference, we are going to present again some of the Innovation Fund projects that we have within the cluster. These are typically projects that are led between different PIs of the cluster and try to, for example, apply machine learning to a particular discipline or advance machine learning by questions that come from a particular discipline. And we have a bit of an outlier in our innovation funding, which is what we are going to start with, namely we have the Ethics and Philosophy Lab, which is a central infrastructure that we founded in the beginning of the cluster to have prominent persons to work on the questions at the interface between machine learning, ethics, and philosophy. And these are 3 postdocs, and the 3 postdocs are going to present some of their work. And we're going to start with a joint project by Erik Reidel and Thomas Grote about AI, trustworthiness, and explainability.
Yeah, thanks for enabling us to present our new project. And Thomas and I are going to present this project together. Next slide, please. So the project is funded by the Baden-Württemberg Stiftung within the project line Responsible AI, and it is a collaboration with the IZDW led by Regina Amich-Quinn, and we have Ulrike von Luxburg and Wolfgang Spohn as associates and advisors. Currently, we are hiring 3 PhD students, and we are really looking forward to this. And the main idea of the project is that responsibility is somehow connected to explainability. We'll briefly expose the main lines involving 3 sub-projects. Next slide, please. The first sub-project is concerned with the connection between explainability and explanation. And explanation has a long tradition in philosophy. In the first part, we'll characterize or try to characterize norms of explanations. What is a good explanation, or what is an explanation, and how is it constrained? How does explanation help understanding? In the second part, we'll try to analyze the promises and limits of explainable AI. Does this have to do with satisfying or violating certain norms of explanation that we previously characterized? Finally, we will also try to propose a conditional-based model for explanation. The idea is that an explanation is based on a chain or set of if-then sentences, so-called conditionals. In these if-then sentences can be generated from the prediction behavior of the trained algorithm. This also connects our project to research in linguistics, psychology, logic, and classical AI, also known as non-monotonic reasoning. So now we switch. Next slide.
Thank you very much, Eric. Similar to Eric, my sub-project is driven by the question of what constitutes a satisfactory explanation. Albeit, in my case, the focus lies on better understanding the moral nexus of explainable AI and ML. In plain terms, the approach that I try to pursue can be described as follows. So we will consider 3 types of cases where explanations might be conceived as morally relevant. First of all, we will take a look at clinical medicine, and here we might ask ourselves, so if an algorithm makes a treatment recommendation, so what sorts of explanations or informations are required for a patient to give her informed consent? Then we will consider judicial decision-making. Say an algorithm made a sentencing decision and you as a defendant want to appeal the decision. Again, what sorts of explanations are required, how much explanatory depth is needed, and so forth. And at last, we will consider algorithmic decisions made by public institutions. Again, to give an example, say a person feels that she has been treated unfairly by an algorithm used by the employment office. and she wants to understand the rationale of the decision. Against this backdrop, the hope is that we are able to identify a set of normative standards for algorithmic explanations, first within the respective domains, and then also on a more higher level. In conjunction with Eric's work, I think that the project really might be useful, might provide some theoretical underpinnings for explainable AI and ML, and could help to guide some research, future research in the field. Last but not least, there will also be a third sub-project led by the IZTW, which will consider the different dimensions in the parlance of trustworthy AI and ML, and will consider different criteria for AI to be trustworthy. So we are really excited about the project, and a lot of news will come up in the future. So stay tuned for more, and thank you very much.
Thank both of you for presenting your project. If somebody has a question, please type it into the question box. And in the meantime, I'm going to ask a first question maybe. Eric, in the beginning, you said you want to talk about, or you want to work on the limits of explainable AI. So how do you think you can sort of explore what are the limits of explainable AI?
Well, so in one sense, I think the attempt of the first sub-project of the first sub-project, so the first, if you go one slide back, please. Well, it doesn't work, but yeah, exactly. So the attempt is to characterize certain norms of explanation, which mainly come from philosophy of science and also epistemology. Epistemology is a discipline that is concerned with how we get to know things, what is knowledge, and how we communicate this knowledge, but explanation is also part of this. And maybe there are certain things that we await from a good explanation, or a rational explanation. And it would be a kind of task to test whether the current methods of explainable AI satisfy or violate these kinds of criteria. That's the idea.
Okay, thanks. So there's a question by Dominic, which is whether there's a trade-off between trustworthiness and explainability. So he says, fair algorithms must sometimes make random choices, and how can you talk about this?
I mean, luckily, analyzing the trade-off between explainability and trustworthiness will be done by the IZTW, so I'm happy to defer the question in a way. No, but in all seriousness, I mean, there might be certain problems when an algorithm becomes too transparent. Because it, for instance, could become possible to trick the system, but generally speaking, I would say I would rather tend to think about that, without explainability or without interpreting, without really understanding what is going on there, it's impossible to achieve some level of trustworthiness in a meaningful way.
Mm-hmm. Okay, and here's the second question.
Maybe for the moment, just quickly, for the moment, I don't know of any result that proves that trustworthiness hinders explainability or something like that. I mean, there are impossibility results for other criteria, but not, I think, for explanation and trustworthiness, but I would be happy to know of it.
Mm-hmm. There's another question I wanted to ask by Konstantin. He asked whether it's possible for an algorithm to give morally satisfactory explanation and still be immoral in some other sense.
I think in principle.
Okay.
Unfortunately.
It's difficult to give a rather short answer to. I mean, Of course, certain sort of explanations can be rather persuasive, but maybe they don't reflect what's really going on in the model. But I would say if the explanation is sufficiently truthful, then I don't really see how. But I mean, that's a philosophical question.
I guess it's a philosophical question, so maybe you're not expected to answer it very quickly. So thanks for both of you for presenting your project. I'd now like to move on to the next project by Thilo Hagendorf.
Thank you.
Here we have Thilo. I hope can you hear us, Thilo? Yeah,
yes.
Looks like you can. And welcome, Thilo. So our next speaker in the Spotlight session is Thilo Hagendorf, who's also a member of the Ethics and Philosophy Lab. And he is going to talk on a different project, which is about ethical considerations and statistical analysis of industry involvement in machine learning research. Please go ahead.
Yeah, hello everyone. Thanks for having me. As Ulrike said, I want to talk about industry involvement in machine learning research. So first slide, please. So what is the starting situation? You all know that there's a great local debate about the Cyber Valley. You can see all the newspaper articles on the side of the slide. So there is industry influence on the machine learning research community, but in general, not just in Tübingen, in general, the quantitative scale of this influence is rather unknown. Next slide. So this is why, together with my colleague Christoph Meding, we wrote a paper which is an ethical and statistical analysis of the field. And basically, we inspected nearly 11,000 papers of the 3 main machine learning conferences over the last 5 years. Next slides. Next slide. Thanks. So here's the list of issues. So we were interested in conflicts of interest. We wanted to know who are drivers of innovation and scientific progress. Is it industry or is it universities? And we looked at social impact considerations and at gender diversity. Next slide. So first of all, you can see that the number of accepted papers at the 3 main conferences is rising from year to year. And we differentiated 3 different categories of papers. So first, there are academic papers. That means papers where all authors have university affiliations. Then industry papers where all authors have industry affiliations, and mixed papers. And in figure B, you can see that the mixed category is growing. So this is the first sign that there are maybe more and more conflicting interests. Next slide. So we were especially interested in academic papers which had industry acknowledgements. And you see that around 15 to 20% of academic papers have those acknowledgements. And those are cases with conflicts of interest. And now the decisive question is, how many papers have conflict of interest statements? And the answer is 3 of 11,000 papers have those or include those statements. So there is room for improvement. I think NeurIPS 2020 is making steps in the right direction with the funding transparency statement. Next slide. Then we looked at innovation, and what you see is, and this is an interesting fact, I think, that you can see that the average number of citations of industry papers is way higher than the average number of citations of university papers. Next slide. We especially looked at trending topics, namely generative adversarial networks, reinforcement learning, and adversarial attacks. And we could show that industry is, so to say, sensing the importance of those topics around 2 years ahead of academia. Then in figure C, we looked at social impact awareness. So we analyzed terms like ethics, privacy, accountability, anonymity, safety, and so on and so forth. And we found that with respect to social impact awareness, there are no significant differences between university papers, industry papers, and industry papers. Next slide. Then we looked at gender diversity. You all know there are gender imbalances in the machine learning research community, and we found that those gender imbalances are even worse in industry contexts compared to universities. Next slide. So to conclude, collaborations between universities and companies are increasing. Conflicts of interests occur, but they are hardly ever disclosed. Then industry research is a driver of innovation, but, and this is now really important to stress, from our study, it is not clear whether this is because industry research is inherently excellent or whether the excellent researchers are just bought up by companies. Moreover, industry papers have no less social impact considerations than academic papers, and gender imbalances are even stronger in industry contexts than at universities. Yeah, thanks for listening.
Thanks, Thilo, for presenting. I would like to start with the first question, namely, if you talk about conflicts of interest, I think this has been discussed a lot in the field of medicine. And as you say, it has not been discussed so much in the field of machine learning. But my feeling is also that the two fields are different in terms of conflicts of interest, because in medicine, there's a company that directly wants to sell its new medicine. What's the English term for that?
Drugs.
It's new drug. Whereas in machine learning, there's often not such a direct product that a company wants to sell. So do you see that there's a difference in these two fields?
Yes, there are differences. So it's your remark is right. We try to sketch what are the effects of conflicting interests in machine learning research. And basically, we said that the effect is that research agendas are, so to say, skewed or distorted. So there's more research which is concerned with, or there's more applied research than basic research, and there's more research with an expected outcome of a product. And yeah, so it's hard to assess the concrete effects of conflicting interests. That's true, yeah. And there are differences between the fields, yes.
Mm-hmm. So there's another question, which is, what is the most important change in policy that you would suggest to improve the situation?
So first of all, as I already said, I think NeurIPS, the upcoming NeurIPS is making good steps in the right direction with obliging researchers not just to make social impact considerations, but also to make funding transparency statements. So this is obligatory in medical journals, and I think the machine learning community is maybe catching up slowly.
That makes me very proud, because I was the one in the board who pushed for that. Thanks. So there's another question. Do you think the results would be different? Oh no, the view switches all the time. Do you think the results would be different if you would also have access to submitted but rejected papers?
Oh, yeah, good question. My intuition would be to say no, but of course I don't know. I would have to think further about this question. I'm sorry.
Yeah,
I think there's no good intuitive answer to that.
And the last one that got so many votes is a methods question. How did you view 11,000 publications from the NeurIPS conference to get your results?
Yeah, it's not just NeurIPS, but also ICML. and CDPR, and we downloaded all those papers with a tool which is called Beautiful Soup. And then we had another tool called PDF to text. So we transferred all the PDFs to text files, and then we could analyze them with a Python script.
Mm-hmm. Okay, thanks a lot. I think we're running out of time, but you see that your work spiked a lot of questions. Thanks, Thilo. And now I would like to transfer to the next speaker, Daniel Weber.
Thanks.
Okay, perfect. I think we have our next speaker on stage. The next speaker is Daniel Weber, who is working on one of the traditional, I don't know whether traditional is a good word for something that only existed since a couple of months or barely 1 year, but he's in one of the standard projects in the Innovation Fund round by Enkaleda Kasnetchi and Andreas Zell, and he's working on human-robot interface with eye tracking.
Yeah, thank you very much. And hello, everybody. As Professor Luxburg already said, in our project, we want to connect robotic, eye tracking, and machine learning. So what exactly does that mean? Let's get straight to the next slide and have a quick look at the project idea. So the main idea behind the project is to teach a robot about unknown objects. On the picture on the right, you can see a robot in front of a table with various objects on it. And we now want to utilize the human gaze to point out an object to the robot. The robot should then segment these objects visually, and together with the class information he gets from the human being, he should learn this object. All of that we want to do in an augmented reality manner. That means we want to use augmented reality classes like the Microsoft HoloLens 2, for example, in order to communicate with the robot. Unfortunately, Microsoft had shipping problems with the HoloLens 2, and we had to start with a classic eye tracker. And we have been thinking about a way to detect the unknown objects first in order to work with these objects for the training part. So let's get to the next slide. In our first approach, we resorted to an existing location proposal method and distilled the output through gaze information. Thereby, our approach consists of 3 steps. The first step is the gaze estimation step. There, a human wears a head-mounted eye tracker, and his gaze is tracked, as you can see on the picture on the left. So in this case, the human is looking at the scissor on the table. But since we need to estimate the human gaze in the robot's frame of reference, we map the gaze point from the human's field of view into the field of view of the robot. This that you can see on the right side. Here, the gaze point is also on the scissor. The second step, on the next slide, yes, thank you, is to actually calculate region proposals in terms that we determine candidate bounding boxes that might contain an object. For that, we use selective search, which is also used by the 2 object detectors, RCNN and fast RCNN. The output is a huge set of possible bounding boxes, which is very large. That's why in the last step, in the third step, we want to reduce the number of proposals in our set and distill it into a more smaller and more pertinent set of proposals. That means we have a subset PG that depends on G and contains only boxes that intersect with the object marked by this gaze point G. Okay, but how does it look at the end? So let's have a quick look at the results. In red, we have the state-of-the-art object detector FCOTS, which we trained on Microsoft Coco as ground truth. And in green, we have the best box in the full set of our proposals. In blue and in yellow, we have the boxes we have distilled out of the whole set. As you can see on the lower left picture, in contrast to FCOS, we were able to detect difficult objects like, for example, the scissor on the keyboard. And in general, the bounding boxes were sufficient for our use case. Summarized, without recall loss, we increased the precision of the location proposals by over 20 times. We were able to detect unknown objects in general. And among the first 3 proposals, we had on average almost 90% accuracy compared to the best box. And yes, this whole proof of concept resulted in a paper, and this was recently accepted for this year's IROS. Finally, on the last slide, I want to give you a little impression what is coming up next. So the HoloLens 2 arrived, and here you can see an interface we are currently working on and are using to communicate with the robot. And yes, now we are looking forward to use our previous results and to actually train the robot about unknown objects. So thank you very much for your attention, and feel free to ask questions.
Thanks very much. So I would like to start with the first question about the gaze estimation. So how do I need to think about this? So you have an eye tracker on, and then so it tracks where you look at, and do you need to stare at the object directly and for a long time, or how quick is that?
So in general, there are 2 different kind of eye trackers. In our case, we used head-mounted eye trackers, so it's basically like a glasses you wear. You can also move around, and then your gaze is tracked. But of course, your eyes are always moving around, and there are a lot of movements in your eyes. So in our case here, in this use case, we concentrated on looking just at one point, and then we pressed the button and said, okay, this point is the point we are interested in.
Mm-hmm. And there was this example on the previous slide where you had a knife like vertically lying, and the scissor and the spoon or whatever it is like very close to it. So how did you know that the person was looking at the knife and not at the spoon, for example?
In this case, we didn't know that. So I mean, they are intersecting. So we just concentrated on one object, and then we looked at which bounding boxes we get as output, and then we compared them to F-course.
Mm-hmm. Okay. And then there's one more question that has been typed in the question box, namely about whether you can envision some applications of your framework to other scientific fields. So it's somehow clear that it might be interesting in an industry context, or so a robot picking up something, but whether you see anything in a scientific discipline.
I mean, the general idea behind the project is to get along with to get over problems where you do not have training sets, and you can generate your own training data. And I think this is also, of course, most interesting for industry, but also there are often problems in scientific sense that there's no not the fitting data set you are looking for, and then you could, in the best case, generate your own data set very fast and much easier.
Mm-hmm. Okay, thanks very much.
My pleasure.
Now, I'd like to move on to the next speaker, who's the final one in this session. Thank you. Okay, perfect. There we go. I see our next speaker on stage, who is Pablo Sanchez. He's working in a joint project by Sonja Utz and Isabel Valera. Isabel by now has moved to the University of Saarland, but initially she was also a member of, and she still is a member of our cluster, of course, and we're happy that she keeps on collaborating with us. So Pablo is working in their joint project, and he's going to talk about exploring ambient and awareness in Twitter.
Thank you so much for the introduction. So I think we can move directly to the first slide, where I will introduce the concept of ambient awareness that appear on the title. This is the process of getting the knowledge about who knows what in the social media network simply by regularly skimming through the generated content. And here the word skimming, in a more general sense, means that this awareness should be developed without active effort from the user. In the context of Twitter, there is work that has studied this concept there, and the experiments conducted show that on the one hand, Twitter users can develop ambient awareness, and on the other hand, that these users can also infer expertise from tweets. So these two findings really complement each other and support each other pretty nice, which is good, a good thing to have. However, they also found out that this only happens for parts of the networks. So this is still work to do in order to understand why this happens and also what type of information is most useful in order to develop this awareness. In relation to the problem of inferring expertise, in the next slide, I introduce the problem of topical group identification. The goal here is to characterize the topical groups, and this is just defined as a collection of users that are interested in propagating information, and we call them experts or broadcasters, and another users that want to search for information that we call seekers. And this interaction will happen in the context of a topic. Again, going back to the Twitter use case, the methodology that works the best uses the metadata of the list feature. And in the figure below, I show the data that you will find on a list. And the idea behind this approach is to use the title and the description of the list. In this case, will be world news and the line right below, in order to infer the topics and then the relation between the creator of the list and the members of the list in order to infer who is an expert or broadcaster and who is a seeker. So the question that this methodology does not focus on, that I present on the next slide, is how do users find the members of the list? Or in a more general sense, how do seekers find the broadcasters? So this is the question that we are interested in our project. And right now, we are focused on a more concrete query that is, can Twitter users find experts within their wall? Here, just as a side note, the wall means the place in Twitter where all the content of your friends appear. So we want to explore in a large-scale experiment using a data-driven approach if and how ambient awareness happens in the wall of Twitter. And we call this in-wall ambient awareness. So the first thing we did that I introduced in the next slide was collecting some data from the Twitter API. So we collected activity of the user, the interaction among them, also list data, the network information, and we performed a first analysis on this data. And some of the conclusion that we got was that there is a cluster of seekers that usually do not interact with many of the broadcasters, but with the data available, we cannot understand why this happens. We also found out that there are some other group of seekers that interact with many broadcasters, but again, we need more information in order to answer the question like, from where comes this interaction? So the main takeaway from this analysis is that we need more information to model in-wall ambient awareness. That's why in the next slide, we argue that a necessary condition to develop this in-wall ambient awareness is that the content of the broadcaster must be visible in the wall of the seeker. So we propose to quantify this, and we propose to compute the average of such visibility that we model as the integral that we saw on the right. And we can see this is composed of a multiplication of two functions that I briefly describe in the next slide. So the one on the left is B of BS, and this refers to the probability of the content of the broadcaster being visible in the wall of the seeker. And the general idea behind our modeling is that this probability should be high when the tweets of the broadcaster arrive at the wall, and then this should decay as more tweets arrive at the wall. The other quantity is OS, that this refers to the probability of online presence of the seeker, and the intuition behind our modeling here is that this probability should be high when the seeker tweets or retweets, and then this should decay. And in order to improve this online presence, we also include the like tweets by the seekers. The problem here is that we only have access to the creation time, so we propose to model the like time with a survival process. So yes, this has been my presentation. Thank you very much for your attention.
Thank you for presenting. So my first question would be, how do you think about evaluating your model? So I think it's very difficult to, I mean, if you want to find a strategy, how I'm going to find an expert on Twitter, you first of all would need to know who is the ground truth of who is an expert, but you don't have that. So how do you think about approaching this?
That's a really nice question, and that's something we are still thinking about. But one of the ground truths that we could use is a Google Scholar. There is a lot of people that is both on the a Twitter network and on Google Scholar. So using the H-index or something related to that, we could have a ground truth.
Okay, this would work if you look for experts in a scientific field of research also.
Yeah.
Okay. There's one more question. Are you looking within a specific domain, and will the domain knowledge matter?
So right now we are only considering 2 domains. We are considering artificial intelligence and also social science. But this is mainly because this is the 2 topics that are more close to our research. But yeah, in principle, as long as we have a ground truth that we could use, we could include any topic.
Okay. Currently, I don't see any questions anymore. So with this, I would suggest that we close the session. Thanks again also to Pablo.
Thank you.
The next session is going to start just in a couple of minutes. It's going to start at 4:30, the presentation by Ingo Steinwart from the University of Stuttgart. So grab a coffee quickly and then come back within the next 8 minutes and we're going to continue. Thanks a lot, everybody.